This talk is sponsored by Central Virginia Node of the Commonwealth Cyber Initiative, and we're a state program establishing Virginia as a global center of excellence in cybersecurity research through supporting research, workforce development, innovation, and at the intersection between cybersecurity, autonomous systems, and intelligence. And each year, CCI and CVN sponsor research and experiential learning projects, and today's speaker is a recipient of that funding. So today we have Dr. Tamer Nadeem, and he's an accomplished professor at Virginia Commonwealth University, an associate director of the VCU Cybersecurity Center, and the leader of the Mobile Systems and Intelligent Communication Lab. And Dr. Nadeem's research spans domains, including network security, robust and secure medical IoT, and mobile edge computing, and next generation wireless dynamic and distributed AI frameworks with applications in smart healthcare, smart cities, and intelligent transportation systems. His passion for wireless networking started during his Ph.D., where he focused on enhancing network performance, addressing issues like channel noise and cross-layer interactions. He's currently involved with several funded projects, including MedKnights, for IoMT device security, NetworkTouch for channeling cybersecurity through haptics, HomePal for assessing loneliness in older adults, D2NN aimed at optimizing efficiency and security in edge networks and IoT devices, and DeepMAC for automated MAC protocol design. His research was funded by several federal and industrial agencies, including the National Science Foundation, the National Institute of Health, the National Institute of Standards and Technology, the Federal Highway Administration, the U.S. Department of Transportation, Commonwealth Cyber Initiative, Siemens Corporate Research, AT&T Labs, Microsoft, Nokia-Bell Labs, and Google. And he currently holds 6 U.S. patents and has over 100 publications in peer-reviewed scholarly journals, book chapters, and conference proceedings. Dr. Nadeem's research greatly influences the evolving landscape of wireless communication networking and IoT systems, and today we can look forward to his talk on haptics for network traffic, monitoring, and situational awareness.
Very good. Okay, morning, everyone. I'm going to present our project or our CCI project, NetworkTouch, which is about haptics for network traffic monitoring and situational awareness. This is done in collaboration with my student, Muhammad Ayat, and also my team at the University of Virginia, Professor Gregory Gerling, and student Michael Perkin. So, the basic idea and the motivation for this project is that computer networks nowadays becoming very complicated, becoming a lot of devices included in these networks, including IoTs, robotics, and a lot of many of these devices. And with this complex network structure, network topology, there is a huge amount of network traffic going on back and forth between these devices. And that actually kind of enticing the hackers to try to attack these networks, trying to reach to certain devices and then try to take over some of these networks. And this is a really significant issues that all organizations suffer from. Like a recent study showed that like about 80%, more than 80% of the US organizations have or has experienced network traffic or network attack. Actually, there's like an increase in this after COVID and everything was online. There was like other studies showing that there is a significant increase in these attacks. So the basic idea to handle or to overcome these cyber attacks is basically there are a well-known tools. It's called like intrusion detection systems, which basically try to monitor the network, try to identify any abnormal activities in the network, and then try to notify the network administrator or network managers to start to take an actions for that. Most of these IDS tools nowadays, though initially they were using some statistical approaches to do this, nowadays depending on the machine learning, or heavily depending on the machine learning tools to detect and to identify potential attacks on the network. The problem with this that these tools provide, because of their nature, they actually provide some false positive alarms for that. And studies show that network administrators or network managers got overwhelmed with these false positive attacks, causing what it called an alarm fatigue, that they started to really start to even to ignore or to be less paying attention to these notifications of the systems. So one way to enhance these IDS is typically using other different modalities of communication with the network administration, including visual communications. We're allowing the network administrators to monitor what's going on and try to see what's the potential attacks or the notification even visually and all the things. However, as I said, like this requires like a huge focusing and continuous monitoring from the network administration, which actually add to the fatigue uh, or the alarm fatigue concept that we mentioned, and that's actually not helping that much. So recently, people started to look at different modalities for communications, that including sonifications, where exactly you get like some sounds, uh, whether it's a notifying sounds or even some like wave of sounds that actually trying to help network to detect or to try to identify whether they can find or there is attack or something going on the network. Uh, Studies also showed that this actually causing a lot of fatigue to the users or to the network admin. It's overwhelming them and actually starting to really ignore them and start to lose interest into that. So what we looked at is basically recent things, which is the haptic feedback. These are well-known type of communications or user interface, human-computer interaction or interface that has not been utilized significantly so far, but been used in different domains, especially like communicating for people with disabilities, actions, music, all these things. And there is like a shy try to explore this into into even like some of the notification of security issues. And we all like we know that like nowadays like the iPhones have all these haptic feedback. Like whenever you get an email, you get something, you get these notifications. And as I said, like there are some tries that trying to look at, okay, can we notify the users whenever he receive an email, whether this email is like a fishy email that has some could be a potential attacks or something like that. So these are very simple trials or simple focus or very limited scope of these of usage of these haptic technologies. So in our project, we wanted to explore this further into really a cybersecurity and see if this type of modalities or interactions could or interface between the human and the machines could be utilized in really enhancing the awareness and the detection of the cybersecurity attacks or all the going on with the network traffic. The main idea here is that we wanted to depend on the human perceptions, the haptic patterns that he receives. As you see that it's not about a notification system, it's more about like we provide a rich information as a haptic interface or haptic feedback to the human. Then based on that, we let the human really try to recognize whether these looks like a normal patterns or these are like abnormal patterns that might indicate certain type of attacks here. We wanted, as I said, like you see here, that we don't want to really notify or send a simple notifications. We want to provide as much as possible of the network information in a form that is reasonable and human can receive it, and we leave the decision to the human to detect or to recognize whether there is something going on or not from these haptic feedback. Okay, so as we see later in this talk that we deliver like we convert the network information into messages, and this is like a very simple concept of haptic feedback, that human just like go there and whenever he use this tool, he can see what's going on in a simple way, and based on his experience or learning process, he can really identify whether this is something there is something fishy or something wrong going in the network, or everything looks fine. All right. So that's what we are going to talk in my talk. So basically, I will go over more overview about the network touch that we realized in as a project in this year. Then we'll talk about some of the implementation designs and the prototype that we developed, and the implementation and the evaluation that we did at the end. And then I'll conclude with simple conclusions at the end. So starting with, so again, the objective of the network touch, as I said, it's not about developing a notification system or a haptic notification system. That's not the objective that we aimed at this project. What we aimed at this project is that saying that human brain and human perception and can really is smart enough and can detect on its own if there is something going wrong or if everything is going fine. So what we wanted to provide is, rather than see, this is just a simple animation, rather than having notification system like as a phone or something, whenever there is a detected anomaly or something, what we want to provide, no, we want to provide a more rich information. You can think of that if the ideal case is to provide the raw data of the network traffic to the human, and then we let explore whether the human can really be able to differentiate between the a normal traffic or patterns of a normal patterns of the traffic versus any wrong or any abnormal traffic here. Given the scope of the project was this project again is funded by CCI, and it's just like a 1 year. So we wanted to start just as a first step to explore this idea, and we wanted to narrow the focus into this project to a simple uh, experiments and simple devices, so that we can show as a proof of concept here. So in this project, we focus on a very simple type of network attacks, which we call it TCP port scan and TCP SYN floods, which I will describe in the next few slides. And we wanted to develop, again, a very simple haptic device that see if the human, or to allow the human to see if he can, by on his own, can detect any of the differences, or see a different patterns in the network traffic, and whether he can detect these type of attacks among normal activities of a network traffic. In the next few slides, I'll just go overview quickly about these type of network attacks to understand what we are looking for, as well as the main idea of the devices of the device that we developed in this project. So network attack is basically, or TCP attacks, for example, most of the traffic when any user that he browsing the internet or streaming a video or wherever, most of the activities that you do in the traffic typically consist of two type of packets, either a TCP or a UDP. And still TCP packet is actually considered a major domain or major large amount of the most of these activities. I will not go into a technical details on the TCP, but what is shown in this slide here is basically in a TCP packets, again, all the packet of the TCP flow of TCP connections is basically has a single format, and to differentiate between the type of the different packets of the TCP connection, of the TCP data here, they have a flag or a set of bits, and through these set of bits, they actually can tell what are the types of the TCP packets that is communicated for now. All right. So to look at, like, just as a simple as that, like if you are browsing an internet and you open your browser on your client, and you want just to browse a certain web page, what your computer or what your machine will do is basically send a specific type of a TCP packet, which basically called a SYN, SYN, as you see in this figure. And it's, again, it's the same format of the TCP packet, but it has a bit flag that is set to 1, and that specific bit flag is called a SYN bit flag. So that's indicating this packet is type of SYN. So if this need to be communicated from your machine to the server to the other machine that has the web page, and in that doing that, the other server or the other end will respond with what we call a specific type of TCP packets called SYN plus ACK, which basically again these are like 2 bits, 2-bit flags that will be set indicating that I'm accepting your connection. So this SYN and SYN ACK is used just to establish a connection between your client, your browser, and the server over there. And once this connection is established, then you will get a lot of data exchange, and these are data packets that these bits are not set. So the SYN bits and the SYN plus ACK bits are not set in these any exchange of these data things, right? And then, as you can see, after the data transfer part, then you have a release connection where your client close the connection with the server through what it called a FIN packet, again, this is a specific type of a TCP packet where you have a specific bit called FIN that is basically used or set to indicate this is like an end or request to close the connection. All right, and the same thing, the server has to respond back, and then that you acknowledge, and then you close this connection. All right. So this is typically the in a normal activities, you can see that you start with just opening a connection with just a very few bits, a few packets of TCP packet of this type of SYN and plus SYN and ACK. And then you have a lot of packets that you exchange the data, you download your web page, you and look at it and all this. It's typically a large number of packets. Plus, then at the end, sometimes you have a network closing the connection. Again, just to show the bits here that I'm referring it's part of the TCP or the packet header here. So you can see this is the symbol. You can see my mouse, and this is like the ACK bit here. And these are the bits that whenever it's set, it tell what this type of this packet, whether it's a SYN or SYN plus ACK, whether it's just a normal data packet and stuff like that. So the attack that happened, these are specific type of attack that has been exploited to attack the network here. And basically, we focus only on 2 type of attack that using these TCP packet to generate these attacks. So on the top figure here, you can see this is the normal activities when your machine, for example, communicate to the server to download anything. And again, this TCP flows of TCP data used in different and many applications like browsing application, email application, video streaming application. So that's all the things. As you can see, normal traffic consists of a couple of packets for SYN and then SYN ACK, and then you start your data, and then you have closing the connection. So some of the attacks people have developed utilizing this protocol, the TCP protocol, to cause some problems or to cause some issues in that. Again, I'm not going to talk about the purpose of these attacks or how to use or how to exploit these attacks. It's a different story, but at least how these attacks are done so that to understand what we are trying to do in this project. So one of these attacks is called a port scan attack or TCP port scan. Basically, you're trying to, a machine, the attacker itself, trying to identify what are the services that are provided by this, by the server. So the server could be providing a browsing server, could be providing, as I said, email server, could be providing printing server, could be providing many server or services to the users. And based on that, if you can, this is one way if how the attackers wants to do is to understand, first of all, what type of services this machine is providing. And based on that, he can target a specific service that he wants to attack this service. So that's what it is. So how the port scan is done is very simple. It's basically, it the send packet of the TCP to a specific port. So a port is like a portal or gateways on the machines. It has a unique ID, each gateways, and each server, it has a like a dedicated ID or a gateway on this ID. So typically the attacker is basically send at every possible ID or portal or that gateway, and if he receive a response, he knows that this is that this server is providing a service here. So example here, like in this second plot here, the attacker send a send at port 0. If there is no service running on that, the server will resend back a reset. And then he continue to scan by sending a SYN to the next port and keep doing this. So wherever, if there is a port that a server is running at, he will send, instead of a reset, he will send a SYN plus ACK, as we saw in the previous slide. So through this mechanism, the attacker actually can scan or identify what services are running on the server. So if you look at that, the activities here, that this type of activities consist of a lot of SYN packets that is looking like that is not normal type of activities. In a normal type of activities, you have only few SIM packets, but too many data packets. But here in this port scan, you have a lot of SIM packet uh, with no other data exchange or anything. Okay. Similar things. If you want to, another type of attack is called a flood attack, which is shown in the bottom part here, in which the attacker in this part is actually, whenever he detects a service running in the server, whether it's a browsing server, or is, as I said, emailing server, to take this service down, or like causing what we call a denial of service, is basically by overwhelming it with a lot of SYN packets. So he sent like a huge amount of SYN packets to that specific port that he detected that there is a service running on it. And because of the service, the server has to respond to all of these requests or all these connections. He starts to exhaust resources and start become like useless or not be able to support all these requests. And this is what we call a denial of service attack. And this is done through this, again, this SYN flood. Again, so if you look at this type of attack, it's basically about sending a huge amount of SYN packets. There is no response expecting, no waiting for a response, nothing there. So although these are very simple type of attack, but these are really popular and very common type of attacks. And this is what we focus in this project as just a proof of concept of the idea that we have. All right. So that's what we wanted to detect. Again, as you see, it's a simple things, but the idea here is whenever you see abnormal activities, especially of these SYN packets, then or acknowledgement packet or anything, that indicate might be an indication that there is something going on. Okay. So what we wanted to do again, as we said, we wanted to develop a haptic feedback system for that. And in a haptic feedback, it's the ultimate goal is basically you can have, as I said, providing information to different regions in your body. And the surface body is really huge that you can utilize it to provide different information at different time with a different meaning. And then the human itself could actually detect and perceive this information and utilize here. Again, since this is a limited project, what we wanted to focus only on a single region of the body, which is the hand itself. And as you can see in this plot, we wanted to develop a haptic device. We're trying to provide some feedback or haptic feedback to the human fingers and the palm that basically will communicate the network traffic to there, and then the human would really try to see if he will be able to differentiate between the a normal traffic or any of these type of traffics here. Um, um, so one of the things that we were looking is what type of haptic feedback we will use here. There are different mechanisms. Some of them is like electrical, where you just provide a very amount of voltage that the human or the skin can detect it. Although this is a nice type of feedback, it give you a high resolutions, it's very accurate and a lot of things, but it's also complicated a little bit. It's like require wires, requires maybe a huge amount of batteries and stuff like that, and sometimes is not very convenient or comfortable to the human. So that's why um, we decided not to go in this project with that. It will be like a future work to explore that. But the mechanisms that we went with in this project is we used the vibration feedback, which is a very popular haptic feedback. And each of these circles you see in the palm, these are like a more actuators that is actually vibrates, or we program them to be vibrated with a different intensity, with different time, uh, to deliver the message that we want to deliver to the hand here. All right. So this is basically the overview or the main idea of the potential here. So Oh, and we will get this later. I will describe this later more. So in designing the device itself, we didn't want to have a wearable device. You can think about we can develop a glove, and then that's where you put these sensors. But we wanted to have more flexible device that allow the users to, whenever he wants to use it, he can use it. If he doesn't, he can actually leave it. So that's it's all not always on, and it's not always bothering the user. So we decided, or we thought about using something like the ergonomic mouse. It's easy to hold on and easy to rest your hand on, and that's exactly the thought and the direction that we took in this project. So to develop such a restable device, or a device that you can rest your hand on in a very convenient and comfortable way, and that device will communicate the information that we want about the network traffic, that these different TCP packets to the human, and then we'll see if the human can really detect any of these activities or not. So in the following, we'll go briefly about the prototype design that we went through, and then we'll talk about how we really implement this, and then the evaluation part. So as I mentioned, that we wanted to develop a haptic devices that is not wearable, and it's not interfering with the normal human activities, with a very minimal wires and minimal noise and all this stuff, right? And we wanted to find a mechanism to communicate the network traffic to the human and see how this will be developed, or how this could be communicated to this haptic device. So initially, we developed the first prototype. As you can see here, it's not like very fancy. It's just like we wanted to have these from a clay. We came up with this shape with the hand, and you can see these circles on that. These are the like actuator motors that we developed for each finger plus the palm part here. You can see the arrows. You can control the direction of actuating these motors in a sequential way or reverse way, or you can control the intensity and all that stuff. So the basic idea was nice, and that was delivering things, but the way that it was designed was not comfortable. That actually distract the users from focusing on or using it, or sensing it, because it just was how to carry it, how to put the hands. It was a heavy a little bit, and that was like a kind of not comfortable at all. And from some user studies experiment we did, we found out it's really basically it's not comfortable at all, and it distract the user. So we went with another type, or another second prototype, which is very similar to the mouse design. As you can see, again, we designed this for a clay part, and we developed all the motors here. And you can see it's more convenient, more comfortable, that the human can rest his hand on, and it becomes from the experiment we found out this is more robust, solid, convenient, and that's what we decided to go through, or to go with in this project. Again, we have used like 15 sensors. Here, we decided to focus on the fingers. We didn't put anything in the palm, but that's basically we put at each finger three motors, or haptic motor, or that provide vibrations to the user here. Right. And from the experiments and things, we found out it's very comfortable. And of course, we'll talk about whether this was like easy for people that have no experience to use it before, and whether this is really human could use it to detect the activities or abnormal activities at the end of our talk here. So let's look at the now is given given that we settled on the device part here, we wanted to see what are the information of how to control these motors on this haptic device, and how we correlate, how we map from between the basic information or the network traffic itself to there. Again, remember, this is not just a notification system. We wanted to provide as much as possible information to provided to the user in a raw format, and then we let the user to see if he can perceive this as a normal traffic or not. So what we did, hopefully that's looking here. Maybe I have to jump a few slides and to get back to this things. So what we decided is the following here, that we said that, okay, we will since we are looking at the TCP attack that I described before, and this TCP attack, as I said, is basically about the type of these packets, and it's about the number or the bits that is contained in this packet. So we said that, okay, what we will do is basically we will assign each finger in the on this haptic device to be like vibrated whenever you have this bit in that packet. When you receive a TCP packet, we just communicate how many, or we vibrate the corresponding finger according to that flag in that TCP, right? And now the next question is whether we will do this for each individual packet, and that's will be too much. We found out that because of you can get a huge amount of packets per second to communicate this physically to the human, it's not feasible, first of all, and it will be a lot of overwhelming to the human. So what we decided is basically that we will go with the concept of we just take like a cumulative information here that for a amount of packet or a period of communication, we look at all the TCP packet and we kind of aggregate all the bits into that. So if you look at here in this figure, we took all like, let's say, we took like 100 or 1,000 packet during this period, and this period we experiment with different period sizes, like, and we go with like 20 seconds, for example. And we look at all the packets of TCP packet that we collected during this period, and we just add, as I said, like all the bits here. So for the ACK bits, for example, out of these thousands, you might have 500 packets that have an ACK bit set there. So we use the ACK, or we set the ACK as a 500, and etc. for the rest of the bits here, like the SYN and the FIN bits here. All right. And what we wanted to see is, or what we wanted to do is, okay, how to communicate this information to the user. We don't want to communicate like the absolute value of this accumulated values. What we wanted to see, and we wanted to come up with a very simple form that's saying, okay, rather than communicating that, what we'll do is basically we will look at like typical average or the moving average of of the values of each individual bit. And what we will do is we just notify the user or provide a discrete information to the user to tell a simple information, whether you have a very high or a normal number of packets with this bit. Like, for example, here we look at the acknowledgement bit here. So if you think about like at specific time, we have the average, let's say it's around 20. So if you get a closer to that, then it's a normal number of acts. If it's too much, then like in the T4 here, it's basically this is need to be communicated to the human in a way that show that this is a too much or too huge, or it's a very or it's moderate increase or moderate moderate large numbers here, or the vice versa is a lower or not. So that's the basic idea here is rather than first providing an information for individual packets, we will aggregate the packets for a certain period of time and provide and come up with a value or the aggregated value or cumulative value here. And then we, rather than providing the absolute value or communicating this absolute value, we communicate just a relative to the average or to the moving average that we collect here. So and so that we can have a very few discrete states that we can communicate to the user. And these states we decided to go with just 5 states that, as I said, a normal, that's like when you are so close to the average, we just provide a certain pattern. Again, we have the flexibility to provide a pattern completely for each finger. So we decided only to use 5 patterns. We did some different experiment with different pattern, and we showed that this pattern might be interesting or like best behavior we receive. So we have this pattern, like in pattern 3, as you can see, it's just like this, like a high vibration, and then you become quiet. This is the normal things. If you have, for example, pattern 5, which indicate that you receive a number of acts, for example, are huge compared to the average one, you get this stairwise pattern, incremental stepwise here. So that's a feeling that, or a pattern that is provided on each on the finger corresponding to that act here. And as you can see, for the other cases, when you have a very low, you go with this going down step wise or stair here. And as the same thing for the other type of moderate values here. So as an example, if you look at the plot here, the thin line is corresponding to the average values, the moving average that we is updated every period of time, and this one, the blue one, is basically the type of the current number of acts for this period that you collected that you counted the number of acts here. And the plot on the left bottom here is corresponding to that. So as you can see at the t time, it's normal, so that's we get this pattern. At t+1, the next period is kind of like a moderate increase. You get this pattern. At t+2, still it's a moderate increase. This again, you get this pattern, and then t3 is normal, and t4 is it has a huge increase. Then you get this pattern. Again, this is another part of the future work, like designing the patterns, designing the transition of these patterns. Again, we because of we have a limited time, we experiment with few patterns, but this is the one that at least we did the experiment with, and it was showing a good results, and that's what we decided to go in the project with this pattern here. So to summarize again, this part, again, as I said, like what will happen is after a period of time, you collect the TCP packet, you count all the bits, and these are the bits that we focus on. These are 5 type of bits from the TCP packets. And what we do is we go sequentially, like start with, we assign the first bit, like a fin bit to this pointer finger here. And then for this period, we show what is or we transmit a vibration corresponding to the pattern corresponding to the value of the bits you received here. And then once you did this, we switch to the next finger, which will be corresponding to communicate the SYN bit here. We experiment to provide all this information at the same time to the different fingers, but we found out that it's not that very solid or robust. So we went through this idea of providing this information sequentially. So typically the vibration that we decided in or we used in this project or this experiments is like for 1 second. So we provide the information of the fin bit for a pointing finger for 1 second, then and then switch to the information of the SYN bit for the next finger, and etc. in this circle things. And we call this circle as a wave. So we provide this wave for this period for this current period where we accumulated all the packet here, right? And as I said, although we have multiple motors on the finger, we can use the different patterns going up and down. The direction could have a meaning, but again, we try to keep it as simple as possible to have a more reasonable control experiment, at least with a very short period of time that we have in the project. And we wanted to see whether it's a successful or not, or whether it has a potential that we continue with this or not. So that's what we decided here. So this is again the overview of the whole system. As I said, we take the packets for a certain period of time, like 20 seconds. We just collect the packets, summarize the number of bits, or for each bit in the packet, we just add them together to get a value. And then this value is basically compared to the moving average. And then we decide what is the corresponding pattern. And then for each of these bits, we provide these feedback or haptic feedback based on the pattern that this bit belongs to each of the finger in a sequential way. As you can see, we don't provide any notification here. We just provide the raw data to the human hands here. So we just give him this information about the number of the bits that you receive in this period, and then we leave him to decide whether this is look normal or whether there is something fishy or not here, right? So and this is like again the final things here based on the same previous slide. As I say, this is like we have the server that take the network traffic in a real time, provide this information to the microcontroller, which basically or convert the number of accumulated patterns to the microcontroller, which basically provide the information to the motors on the sensors here. And actually we added a button on the left side, like a mouse button, that actually used to feedback for our experiment. So basically we wanted to see that whenever you detect an irregular pattern here, please press the button. And that's the button that we use to collect some feedback from the user in the real time to see whether he will be able to detect any abnormal activities or not. So jumping to the experiments quickly, we used like a 10 participant here. Again, this was a small set of experiment, just again for us time limitations here. These people, they were mainly graduate students and others, they were not really receiving any training to that device before. This was the first time for them. We found out actually if we can isolate from the surrounding noise, it actually helped them a lot to focus on the activities, and they can detect how to or to be able to detect of monitor or to assess rightly what is going on. We ask about some of the we have like a two set of experiments. Some of these the first set is basically simple experiments to see if the user were able to differentiate between different patterns, different haptic feedbacks or not. And then the other set of experiment is basically we providing a real network traffic with an attacks in between and see if they can detect this attack or not. And that's what I'm going to provide in the next few slides. In this slide, for example, is showing one of the simple experiments that we asked them, or which basically we say that okay, uh, you have five fingers. You put your hands on the device, and now we will provide a specific pattern for each of these fingers, the same pattern, and then in one wave, like in one round, and then in the second wave, one of these fingers will have a different pattern, and we wanted to see whether the user will be able to detect that pattern or not. So it's simple experiment, but we wanted to see if these patterns really human can differentiate between these patterns or not. And as you can see, with like almost 90% or 95%, or more than an average of 90%, they can detect the change and the pattern. And the X column here is corresponding to the finger itself. So we found out some fingers is really more sensitive than others, but again, it's a slightly different or slightly variable. But again, this is part of the experiment that we wanted to understand how the human hand sensing or how the different fingers perceive the different sensing information or can differentiate between different sensors here. But in total, as you can see, with a high accuracy, like 90%, people could identify the finger that is corresponding to an individual uh, that has a different pattern in that thing. So that was a good thing. The other experiment here is basically what we did is we again we provide a wave of information or like a same pattern for all the fingers, and only randomly one of these fingers will have a different pattern. And we wanted to see whether the user can detect this pattern or identify this different pattern or not. Again, for different fingers, we have the same results, and you can see is almost like 80%, 85% or more. The human was successful, or the participant were successful to detect the change here and identify which finger and which pattern was that pattern that is corresponding that he observed here. So these are simple experiments, as I said, just to verify the device itself that we design, to verify the idea of detecting different patterns on the fingers or the pattern design that we came up, whether they are differentiable or not. And that's what we decided here. So the real experiments or for network security experiments is shown in this here. And this is again, it's a simple things. Like what we did is the following. You can see the X time is just like a period of times here. And the white part below zero is basically it's a normal network traffic. So we give the user the device, say that, hey, we have a normal type of traffic. And then you will have a part of attacks and try to see which attacks you are. So what we did is basically we trained the user for a few minutes on individual patterns of the attack, like when you have a scent flood attack, the user we use he put his hand on the device, he observed the pattern or what the sensations he got from this scent flood. He also observed the sensation we got from a normal traffic, and he got the sensation of the port scan attack. So these we said we have two type of attacks and plus the normal traffic. So we gave them a training for like half an hour before that, try to saying that this is the normal, this is the SYN attack, this is the port scan attack, and then the experiment is saying that okay, we will give you now a traffic. Part of it is normal, and then you will have some attacks in between. And let's see if you can be able to differentiate these attacks. And whenever you feel an attack, just press the button on the haptic device as we showed in the previous slide. So you can see that the region here from up to 0, this we just use the period numbers here. It's a normal type of attack. And then for these from 0 to 7 here, we give a type of attack or we give like these type of 3 attacks during this period in a random time. It's not a fixed time. We give them just a randomly uh, pick a time. We provide one type again of the attack, and then we provide and continue do this, and then we switch back to the normal attack here, right? Each row here is corresponding to one of the participant, as you can see. So, for example, participant here, this participant 2 or participant 0 here, kind of press the button for 2 attacks at the same time, which might not happen at the same time. That's a confusion. And then he push an attack on the second one, right? Same thing in the second one. The second participant, he detected an attack at the beginning, and then he found another different attack and others, and then another attack. Again, we provided like 2 SYN attacks plus a port scan attack. So we provided like 3 attacks within this region in a random time. And as you can see, and all these pattern or these participants with a high accuracy detected the attacks in the same order. Some of them were like detected outliers attack, like this participant 6. He came very early during the normal traffic. He said that he found an attack here, and others were kind of like late in maybe in their response in pushing the button. That's why it came in the period after the attack it happened here. But in total, as you can see here, that users were able to detect the attack, detect that happened, to differentiate between, although they are not an expert, they just had a very short training on these patterns. We understand these are a simple experiment with simple type of attack, but at least it showed the potential that yes, with a very few training, user subconsciously his brain get trained on these normal traffic and also the type of attack traffic, and can detect the abnormalities and provide these attacks. Remember, this is not a notification system. It's just we providing the raw data to the human, and then we let the human to decide whether there are something fishy or there is an attack or not. So that's what we're showing here. We also looked at like some, as I said, qualitative experiment to ask questions about whether this is convenient, whether it was easy, whether it was using to use. And you can see that it's the rank is from 1 to 5, with 5 is the high. So we were looking at the size, almost like 3.5, almost of them saying the size was of the device was reasonable to use. It's 4 with average 4. It was comfortable. It averaged almost close to 4.5 or 4.8. It was easy to use, and it was simple in instruction, and it was good to use. Although we have outliers, that's fine. And we know that the sample experiment or our sample of users or participants are few, but again, this is just for the limitation. We couldn't have a large scale experiment here. But again, this is whole idea of this project is basically to show a proof of concept of whether we can do this and whether this haptic feedback could be really interesting or has a potential to be utilized to detect, to depend on the human brain to detect subconsciously the attacks itself or not. That's what we the original goal of the whole project here. So to conclude at the end, we developed a device, an ergonomic hand-rest device. It's non-wearable. Again, it's like a check-in. The users, network administrators can come, observe what's going on, and maybe you can leave. We can use it in different way that we can summarize, give some information from the recent time or wherever it is. So that's something that not to overwhelm, not to cause any a long fatigue for the human. Again, we didn't do any processing on the network traffic or the raw network traffic so far. It's very simple. We provide the raw data in a very just condensed or summarized way. That's the only thing that we did. We used in this experiment, we focus on, as I said, a simple TCP attack, where we looked at the flags or the bits of these TCP packets, and we derive or we provide information or map these bits information to the 5 fingers of the user. And we did an experiment with 10 users that show that they are really able to detect and discriminate between the different type of attacks and the different type of attacks from the normal traffic in accurately in at the right time fashion to this. Again, this is just a first step toward this haptic feedback for cybersecurity. We want to expand. There's a lot of directions we can expand this and make the problem really more complicated. So far, for example, here we are talking about different, we use a single type of activities of a single user. What if you have multiple users going on? That's what we wanted to explore, how to can differentiate between the users, and can provide this information also to the network administrator to monitor that. The type of information that we provide, we use here a TCP flags, but maybe we need to provide additional information. Maybe it will be useful to enrich the information or enrich the knowledge of the user that who is monitoring these traffics, and then can detect something more interesting things, and also how to deliver this information. We showed a very simple mechanism so far, but with this technology of this vibration or haptic feedback, you have a different ideas you can go, as I said, like a pattern, the intensity, the direction. All these are a lot of information. Plus, we only focus here on just the hand. What about the other regions in the bodies, whether we can utilize this to provide a rich information about really what is going on, and whether it could be used to detect additional, more complex scenarios here. So that's basically the outcomes for this project. Show the potential of this haptic feedback for cybersecurity. It's just, as I said, a small step toward that, and we are optimistic about this, and we will looking to support or to come up with a larger project for this with a larger fund to support a larger scale a project about this cybersecurity. Thanks for listening, and if you feel free to ask questions now. You have my emails before, and also you feel free to contact me later on if you have any questions. Thank you.
All right. Thank you so much, Dr. Nadeem. We really appreciate you taking the
Thank you.
time out.
Thank you.